Math 2, 9.4, greatest common factor. You learned how to work with the greatest common factor back in elementary school. Yes. So that is review. Factor each polynomial using, I'm going to put GCF. What does GCF stand for? Greatest common factor. Good. Okay. Before I do that, I'm going to review first, and I should have done this before I wrote that intro piece, but I'm going to squeeze a review in there anyway. On the review, I want you to multiply 3x parentheses x plus 5. Remember, we've talked about this for quite a few days now. This is like our third day where we've talked about, actually, we've done it since last unit. You multiply the coefficients and add the exponents. So what is 3 times 1? X to the what when you add? Second power. Plus, there is no x here to add any exponents, but you still multiply. What does that give you? 3x times 5 is 15x. Do you guys all agree? Okay. What we're going to be doing today is working backwards. I need the talking to stop, please. I'm going to give you this, and you're going to have to figure out what was the original problem to start with before distribution was done. Okay, so I'm going to give you some tools. Now, the tools I'm going to give you right now, not everyone will use the whole time. Some of you will just be able to look at it and figure it out. But I'm still going to give you the tools just in case you ever get stuck. Okay, so what happens when you start with this, when the answer is the problem, and they're asking you to factor using the GCF, or factor out the greatest common factor? This is what our answer should look like in the end. Okay, so what you do is do your factor tree. That's how we're going to start in the beginning. Besides 1, does 3 break down into anything? No. So I'm just going to write 3. How many x's do we have? Okay, 15. What does 15 break down into? And how many x's do we have? Just a 1. Do you agree?
This is 3xx.
Right here? Yes, 3xx because of the x squared, 3, 5, and x for the 15x. Okay, I am going to go through and circle the common factors. Okay, so there's 2 terms. On the 3x squared, these are my factors. On the 15x, these are my factors. What are the common factors? Do they have a 3 in common? Do they have a 5 in common?
No.
Do they have an x in common? Do they have another x in common?
No.
So what I've circled right there is the greatest common factor. They both have a 3, and they both have only one x in common. Would you guys agree?
Yeah.
Okay, now there's 2 ways of thinking about it. Right here, if you didn't have that there, remember you multiply your coefficients and add the exponents. 3 times what is 3? 1x. Now x to what power if I want it to add up to the second power? 1. Would you guys agree? 3 times 1 is 3, and 1 plus 1 is the x squared. Yes or no? Is x actually what was left over here? Yes? Okay, the second piece plus 3x times what is 15x? Just 5, not 5x, just the 5. 3x times 5 is the 15x. And is 5 what was left over here?
Yes.
X and the 5. Yes. Okay, now let's take a look. So this is what we're doing today. This will be the original problem. This would be your answer. And I told you guys you're working backwards. Is this indeed what we started with over here?
Yes.
Yeah, do you see how that works? Okay, let's try another one. Number 2. Number 2. Listening, please. This next one, I'm going to do the factor tree again. I'm going to give you some shortcuts. If you don't want to do the factor tree, that's perfectly fine. 14x to the third minus 42x squared plus 21x. And because you have calculators, you can figure out what numbers go in. Okay, break down the 14. break down the 42 and break down the 21. Go ahead and do that now. I'm going to give you guys a few seconds to break down each one. I'm going to move this off screen so I can break them down. You should be breaking them down on your own. Alright, do you guys have this? For the 14x cubed, it's 2 times 7 times x times x times x. Yes or no? Yes? For the 42, do you have 2 times 3 times 7? And then the x squared, x times x. And the 21, 3 times 7, and just the x. Yes or no?
Yes.
Okay, let's circle what they have in common. Do they all have a 2 in common?
No.
What about that 3? Do they all have the 3 in common?
No.
What about a 7?
Yeah.
What about an x?
Yes.
What about another x?
No.
No, I'll have kids say, yes, there's another x. These two have another x in common, but does the last one have another x?
No.
It has to be on all of the terms. Okay, so what's the greatest common factor?
7.
Not just 7, but 7.
X.
X. Okay, so let's say we don't have this, and we'll check how it does work. 7 times what is 14? 2. You have to add the exponents to get x cubed. If this is already 1, what power goes here? 2. Do you guys agree that 7 times 2 is 14? X times x squared is x cubed? Yes or no? Okay, let's look at what's left. Was it indeed a 2 and an x squared that was left? Yes or no?
Yeah.
Okay. Minus, and the only reason I'm covering that is because not everyone's going to be doing it that way, so I'm trying to show you both ways at once. Minus 7 times what is 42? 6. What exponent do I need here so that it adds up to 2? It's already a 1 out here. 1 plus what?
1.
Another 1? At 1 plus 1 would give me the x squared. Let's check to see what's left over. Yes, is 2 times 3, 6, and then the x left over.
Yeah.
The question that was just asked, if you did not hear him, is it okay if we just put 6x and not x to the first? Of course. All right, plus 3. Now, I often have kids say, oh, there's an x there, so it must be 3x. Is it 3x? No, because 7 times 3 is 21. What's x to the first times x to the first? X to the second. And is there an x squared there? No. Also, if you look here, it's just a 3 that's left. There are no more x's, so it's just the 3. This there is your, sorry, did not mean to put that extra parenthesis there. That there is your answer. Questions?
Is that it?
Okay, that's it for this problem, but I want to go over this shortcut, because how many of you can look at this and see 14, 42, 21 and know that 7's the greatest common factor? Okay, so if you can look at that and know that 7's the greatest common factor, do you have to do all the breaking down?
No.
That's only if you're stuck and you cannot figure it out. Okay, how do we figure out our x's? This is x cubed, this is x squared, this is x to the first. What variable did I take out?
6.
X to the first. I will always take out the smallest one because that will be the greatest amount they have in common. I'm going to repeat that. Do I take the larger one or the smaller one?
Small.
Always the smallest, because that will be the greatest amount they have in common, greatest common factor. Does that make sense?
So no matter what it was, it just has to be the
It's always going to be the smallest exponent. And it may not, our smallest, yes, exponent. It may not even have a variable. We'll see somewhere it doesn't. Okay, Let's try another one. 18a plus 27. Now, you don't have to do the breaking down. If you can figure out what's the largest number that goes into 18 and 27. Okay, 9 or just 9a?
9A. Oh, just 9.
Why just 9?
Because there's not 2 A's.
There's not another a here. Do you guys see that? If you were to break this down, what would that be? 2,
9.
so 2, 3, and 3? And a? And what would 27 be? Is that 3, 3, and 3?
Yeah.
When you look at what they have in common, do they have an a in common at all?
No.
No. There's no a over here. So if a is not in common with all of them, or your variable's not in common, then you only have a constant coming out, no variable. All right. 9 times what is 18a? 2a. 9 plus what is 27? Or 9 times what is 27?
3. Or 2. 3.
3. And that there is the answer. Did anybody work ahead of me and get this answer? A few of you. Did anybody do the factor way? I know I said I would, and I still kind of did. Anybody do it this way and still get the same answer? If you look what's left over, 2a and the 3. Okay, really quick, really quick, and this is where people mess up. How do you know if you have the right answer or not? First off, look at the original. How many terms is this? Is this 2 or 3? So we call it a trinomial. Cover your GCF. Is that a trinomial in there?
Yeah.
Yes. This is a binomial. Is that a binomial? Yes? Okay, that's one thing you should check. Check it. Second, you said just check it. Like work it out. If you distribute, would it get this?
Yeah.
Yes. The third thing is what everybody forgets. So please do not forget this. Look.
Smiley face.
No, not yet. Look for a GCF. Sometimes kids mess up and they say, oh, 3 is the GCF. If you guessed 3, it does factor, but it's wrong. So you look in here. I'm going to cover the 9. Does 2 and 3 have a common factor besides 1? Is there anything that divides into 2 that also divides into 3? No. So this is done. I'm going to show you one eventually where kids mess up and this comes into play. We'll talk about it when we get there. Okay, questions? All right, number 4. 7y to the 3rd, z to the 4th, minus 15y z squared. Ignore the variables for now, completely. Look at only the coefficients. Does 7 and 15 have a common factor? No, if you broke it down, 7's prime, it's just 7. 15 is 3 and 5. There are no common factors as far as numbers go. So now let's look at the variables. Using the shortcut, would I use y cubed or y to the 1st? I used the smallest. Which one would I use? Y to the 1st. Would I use z4 or z squared? Z to the 4th or z squared? Z squared because it is the smallest. If this one has 4 and this one has 2, the maximum amount they have in common is the squared. Does that make sense? Yes? Okay. Parentheses. Remember, there is a 1 here. You don't have to write it, but I'm going to erase it in a little bit. 1 times what is 7? There's a y to the 1st. Y to the 1st times what is y cubed if I'm adding exponents? Y to the 2nd, because 1 plus 2 is the 3, yes or no? Okay, what about the z? I have z squared. I don't have enough. I need some more. Z to what power so it adds up? Is it also a z squared? Do the 2 and the 2 add up to the 4? Okay, minus 1 times what is 15? Should I put an extra y here? Can anybody tell me why it would be wrong if I put a y there? Because that would be y to the 2nd. Do I want y to the 2nd? No. So if you have your GCF is y1 and you see the y1 already there, should you add another y? No. There's a z squared there, there's a z squared there. Should I add another z? No, because if I have a z, what does that mean? Z cubed. And is that z cubed? No, so it's just 15 by itself. That there is your answer. Let's do a quick check. 2 terms and 2 terms. Did it work? When you distribute the y to the first z squared to these two, do you get this? Okay, what was the one thing that kids always forget to check? Is there still a what? Greatest common factor. Is there still a greatest common factor in there? Does 7 and 15 have a common factor? These have a y and a z, but does that one have a y and a z? No, so this is good. This is your answer. All right, let's try that tricky one I was telling you guys about earlier. Number 5. Oh, no, this is not the tricky one yet. I lied. 4x cubed plus 12x squared plus 8x. I'm going to let you try this one on your own. You decide which method you want to use. If you like the breaking down, then break it down. If you like just looking at it and say, oh, I know the largest number that goes into 4, 12, and 8, then do that. You do not have to do this. You don't. How many of you can look at that and know that the largest number that goes in is 4? Okay, so let me cover that. The only reason I'm doing that is because I do have some people still using it. So ignore that for a second. 4, x cubed, x squared, x to the 1. Which one do I take? X to the 1. Those of you that are doing this method, did you end up with the same thing? They all have a 2 in common. Another 2 in common. That's it as far as numbers go, and they have 1x, and that's it.
So you don't got to do all that, right?
You do not. You do not. So if you can look at that and say 4x is the greatest common factor, you want to be here eventually and not have to do all the breaking down. Okay, what am I left with? 4x times what is x to the third? X to what power? Second, so that 1 plus 2 is 3, right? Plus 4 times what is 12x squared? I heard it. What is it? 3x. Does that multiply to 12 and then those add up to x squared? Plus what? 2. 2x or just 2? Just the 2. That there is your answer. 3 terms and 3 terms. Do a quick check. If you distribute, it works. Is there still a greatest common factor between 1, x squared, 3x, and 2? This is our final answer. All right. Here's the tricky one. Mendoza.
Stop, please.
Okay. 32 z to the 4th minus 80 z to the 3rd plus 112 z squared. I'm going to let you guys do this one on your own, whether it's by factor tree or just by looking at the numbers.
Yeah, it can't be higher than 12. It can't be higher than 12. It can't be higher than 12. That's not higher than 12. What?
I was wondering where you were getting 12 from, but Mendoza, good observation. If it was a 12, you would be correct.
Yeah, but it's
112.
I hear you, bro.
I'm just letting you know.
More politely, because
Okay, let's ignore the numbers for now. At least with the variables, can we all agree it would be what? Z, no, not the numbers, just the z to the what power? Z squared, because we always take the smallest. Okay, I hear a lot of people saying 8, so I'm going to work with that one. If you didn't get that, don't erase your work. We're going to check 8. You guys said z squared, correct? Okay, 8 times what is 32? 4. 4z to what power? Good job. 4 times what is 80? Z to what power? 1, which is nothing, plus 8 times what is 112? 14. Z or no z?
No Z.
Because z squared and z squared is already taken care of. Now I will tell you this. You look, 3 terms. Are these 3 terms?
Oh,
Is it 3 terms and 3 terms? Yes or no? I'm going to cover that. Or is it a trinomial and a trinomial?
yeah.
Okay. If I were to distribute this, would you guys all agree that this equals this?
Yes.
Can anybody tell me then why I would mark this wrong if that was a test question or even a quiz question? Okay. Here's the deal. Here's the biggest question I get. Mrs. Torres, how can I tell that this is wrong? Would you all agree it's a trinomial and it follows that it's a trinomial? And when I distribute, it works. We know it works. How can you tell it is wrong? That little note over there that I said kids always miss, what does that note say? Is there still a greatest common factor between 4, 10, and 14? Ooh, what is it? Then that means that original GCF was not big enough. So I'm going to give you a quick shortcut on how to find it. What did you guys just tell me comes out of all of this? You take the 2 and you multiply it by the 8. What's 2 times 8? So 16z squared is your true GCF. I heard a few of you say 16. Yes, you were right. I just didn't want to say it out loud. So what do you have to get used to that kids always forget? Look in here and ask yourself, is there still a GCF? If there is, take it out and multiply it by your original GCF. Okay, 16 times 32. Does anybody have that? 16 times what is 32? 2, and it's still z squared. That part you guys had was correct. 16 times what is 80? Does anybody know that? You have a question? 16 times what is 80? 5. And it was still z. You guys had that part right. 2 plus 1 is z cubed. Plus 16 times what is 112? 7 is correct. Do I have any z's over here? No. Z squared is already taken care of. That is the right answer. Now when you check here, does 2, 5, and 7 still have a GCF? No. Do they all have a z?
Yes.
These 2 do, but does that last one have a z? If it did, then you'd still have to factor that out. Questions?
Oh,
What if there's a greatest
Then that's what was said. Guys, that was a really good question. What if, let's say that 7 wasn't there. Let's just pretend. You factored it and that was it. You were done. How would you know that's still wrong? Is it still a GCF? If without this, what's still in common? It's not a number, it's a letter. What do they still have in common? A z, which means another z would come out and it would have been z cubed. That's if that 7 was not there. If that was this different problem originally. When you did your GCF, you got it, you got this, you still have a variable. Is that still wrong? Yes. All of your variables need to be out. All of your greatest common factors on your terms, your numbers should be out. One last one. Okay, number 7. This is one that kids mess up every year in the test, so please make sure you're paying attention. X plus 3 quantity squared minus x plus 7 x plus 3. Okay, this is a binomial. It looks wonky. There's 2 terms. This is my first term. This is my second term. It is a binomial. My first term has 2 factors. I'm going to actually write them out like this. And my second term has 2 factors. I'm going to write it out like this. The second one staying the same. I just rewrote the first one so there's 2 of the bases. Does everybody see the 2 terms? First term, second term. Does everybody see that? Okay. Each term has 2 factors. That has 2 factors. and that has two factors. X is not a common factor, by the way. X is not even a factor. X plus 3 is a factor, X plus 3 is a factor of this set. X plus 7 and X plus 3 is a factor of this set. What was your question?
Do you distribute the negative?
Good question. We will not distribute the negative. We will not do double distribution.
Can you do the box on this one?
Okay, we're not going to do the window method, the box method. We're not going to do any of that, but that's what kids are always tempted to do. We're still doing greatest common factor. What factor is common between the two of them? X plus 3. Is there another X plus 3 in common, or that's it?
That's it.
That's it. So you take your X plus 3 out in parentheses, bracket. When this X plus 3 is factored out, what does that leave you with? Another X plus 3 minus what, Kashari? X plus 7. And they do have to go in parentheses, like that. That there is your final answer. In this class, we stop there. We don't go any further. In advanced math, or even math 3, you'll distribute, combine like terms. But for us, for now, we stop here. This is it. That's your answer. Definite test question. All right. Make sense? Okay, take your packet out, please, and let's get to work. No, I did not say pack up. I said take your packets out.
Who heard Thomas? Thomas, come here. Hey, what you guys do?
Raymond, put that away, please. All right, thank you. First one. What goes into 3 that also goes into 9? 3. Do I have to do the factor tree if I don't want to? Is my GCF 3 or 3T?
3.
Just 3 because the second term does not have any T. Okay. 3 times what is 9T? 3T. And that's it because the 3 is taken care of? No, minus what number?
1.
Don't forget that 1. Good job, guys. 3T minus 1 is what's left over. Do not forget the constant 1 still goes. Because remember what I was saying earlier about if it's a binomial to start with, it still has to be a binomial. If I forgot that one, it would have gone from a binomial to a monomial, which is not okay. So you have to keep the number of terms. If you forgot the 1, when you distribute it, you never get the negative 3. All right, what goes into 12 that also goes into 28? Anybody? 4. 4J or just 4?
Just 4.
Just 4. All right, 4 times what is 12? I don't have it back there. Do you have one? Do you have a cube?
Oh. Plug it in your computer.
Yeah. 4 times what is 12?
3.
3. And then do I have any J's? If so, how many?
3.
3 plus 4 times what is 28? Any J's? If so, how many?
0.
None?
That's it.
That's it. Do you know where that paper's at? Huh?
Can you put these on the test? Like a whole lot.
You know what, sorry, people actually, here you go, struggle with those most of all. I don't know why, but they do. Oh, yeah.
Like an egg. What is that? An egg.
All right. All right. What goes into 72 that also goes into 63? Anybody have that? Does 9 go into both of them? 8 is one of the leftover factors. 8x, I'm sorry, 9x or just 9?
Thank you.
All right. 9 times what is 72? 8 what? Minus 7? Okay. No. Shh. Guys, I'm going to jump to number 5. Can anybody tell me what goes into 30, 18, and 54? 3 goes into all of them to 6? Okay, now if you guessed 3 and you factored, would you know it's wrong when you see that there's still a GCF?
Yes.
Okay, so 6 what, since they all have a variable in common? Good job, guys. 6n. 6 times what is 30? Into what power, so it adds up? Second, minus 6 times what is 18? Did you say 3n? And that'll make the n squared. Plus 9. 9n or just the 9? Just the 9. Good job. All right. You don't have to do, this is your work. That's it. Just the answer. I know that's kind of wonky and weird, but it is what it is. All right. I'm going to jump down to number 18 with you guys really quick just to see what one of those look like. What was that? I'm going to jump down to 18 really quick so if everyone can take a look there. Okay, 18. 2 terms. Do you guys see the 2 terms? The first term has 3 factors. Please stop the talking. The second term has 2 factors. Does everybody see that? 3 factors on the first term, 2 factors on the second term. Do they have any common factors? If so, what is it? Do they have another x minus 2 in common? No, this one has 2 more, but does this one have any more? No. So the only greatest common factor here is x minus 2. Bracket. Here, instead of writing this out twice, how can I also write it? Good job. X minus 2 squared plus what? X plus 8. And this is how we leave it. We do not go any further. Make sense? Okay, can you guys flip over to the back so I can just talk about a few of them really quick? I'm not going to do it all the way with you, but I just want us to at least show you how to set some of them up. Did everybody get that one?
They didn't do any work.
There's no work. No. Okay. Guys, 19. Length and width of a rectangle. Find the area. Express your answers in this form. Be sure to include units in your answer. What's the formula for the area of a rectangle? Length times, or base times height, which is, it's either length times width or base times height. They mean the same thing. So length and width. What is my length? What is my width? And it asks you to, notice this is review. It says review. The word problem is not review, but this is. What is this method called? Double?
Distribution.
Distribution is correct. Can you see that? Or the box method, or the window method, whatever you call it. Okay. Does everybody see that? Okay. You are going to do this one on your own. Once you get your answer, it'll look like this. A number x squared plus a number x plus a constant. Once you get your answer, you write it in parentheses and put inches squared. Why? You do need to remember that for the test, and this is a test question. Why do you have to put inches squared? Because it's area. Length times width, inches times inches is inches squared. Yes or no?
Yes.
All right. This is review right here as well. This is a double distribution or the window method. I'm going to rewrite this one so you guys do not forget.
We have to stack our chairs.
You do have to stack your chairs.